Right. So let's apply this now to an example or the idea of what's called value at risk. It's still everything we're doing. We're just giving it some structure or talking about ideas. So this is referred to as value at risk. It's just an application of the same idea. So it says a company expects to receive some cash from a customer in a month. The cash will be in an overseas currency, and the directors are worried about exchange losses. Yes. And these are the changes in the amount received in sterling due to fluctuations in its value in relation to foreign currency. So it says here that the treasurer has used a simulation package to predict the most likely outcome, namely a gain of 5,000. So think of that like the mean. We're hoping for 5,000 pounds. I could almost create, I'm going to create this. Yes. So I'm hoping, I'm going to have two tables, so to speak, here. When I say two tables, so you can see what's real in terms of this is my mean. So I'm expecting 5,000 pounds. Yes, I'm expecting 5,000 pounds. That's the mean. Remember, this the Z-score for this is also 0, if you think about it that way. Now, let's just go back up. The question then says, however, the currency is volatile and the monthly standard deviation is equivalent to 12,500. So in simple English, this just means that this could go, I'll just change my pen color. This could fall 12,500 this way to one standard deviation. So if it falls by one standard deviation, that's 5,000 minus 12,500. Are you happy about that? You can see here, if it falls by one whole standard deviation, I'm going to end up with a loss of 7,500. That's what this is sort of saying. But if it went up by one standard deviation, I will end up with, 17,500. This is one standard. I mean, the distance from here to here is 12,500. That's what that means by one standard deviation. And I've told you how we calculate the 12,500, right? So that's really it's about distance, isn't it? I'm 12,500 away, aren't I? Between negative 7,500 and 5,000. And I could do the same thing again. I could find two standard deviations. So two standard deviations, right, would be 2 times 12,500, which is 25,000. So this will take me again, two standard deviations will take me to, so 25,000 plus 5, that's 30,000. Yes, and I could be basically 5 minus 25,000. 5,000 minus 25,000 is minus 20,000, or I could be two standard deviations here, so that could be minus 20,000, right? And I could keep going if you like, and let's do a third one just because I'm teaching. 5,000, 12,500 times 3 is equal to 37,000 plus 5,000. So we could be all the way up here. If it did, I mean, that's what we're sort of saying. Here we have 3 standard deviations and we're at 42,500. This is 30,000. And I could have exactly the same thing in the other direction. Well, 5,000 12,500 times 3 minus 5,000, and that's minus 32,500. Okay, that's the first point that we have to consider. Now we're going to apply some Z-score discussions, right? I can find information. We can have. Remember that we know this is 68. Well, when I say 68, we can coming from here. Using the Z-scores, I can discuss and understand and look for things. So I can say, what is the probability that the value will be? I could ask anything, and that's what we're going to do in this case. So what is the probability that we are going to be if you like, what's a 1% probability? A 1% probability is using the Z-score tables to find out what's going on from 0, kind of coming all the way up this way, right? I could do the same. What's the 5% probability that the value would be less than a certain amount, right? As you understand, if I'm saying what's the probability that the value will be a 1% probability in this area, I'm also asking that question. That point is also saying, if it's saying what's the probability there's a 1% here, I might also be asking what's the probability that there's a 99% chance it will be in this section. You see, because underneath this curve is 100%. So every time if I want to find what 95%, what's the 95% chance that what's the chance that the probability is above 2 standard deviations? All I need to do is to find the probability of the other 5%, and I can just subtract it. So that's what we're going to, well, when I say subtract it, well, that's what we're going to do. And that's how this is done, because the Z-score tables, remember if you watch that, always start from here. The Z-score tables give you data or information from the beginning, the 0. So that's the important thing. So watch how the question is phrased. So let's go to the question, and I think that's the kind of key point. Let me keep that, and let me now go to the question. And here is what the question looks like. The question says here, well, let me just focus here. We're interested in a 99% confidence. Let's just say we're interested in a 99% confidence. So that means, and I will explain that, so you can then illustrate it. A 99% confidence means I'm interested in what the situation is here for 1%, right? Because this is a 99% confidence is this, but I'm interested in the 1%. So let's use the Z-score tables to find the 1%. So what we have in the Z-score tables in terms of a 1% here is that what is the Z-score for 1%? So if I'm looking for 1%, I'm looking for 0.01. Yes, where is 0.01? Remember, I'm starting from the most extreme part of the Z-scores. I'm coming from here. I'm coming from here, so I'm starting from here. So I'm looking for 0.01. And if I look here, I can see this is 0.009, this is 0.00990, so this is just about closer to 0.1. So it's somewhere in between here. So this is, the Z-score is 2.33. Yes, so I'm going to go across this way and then look up this way. This is the 100th, isn't it? And this is the 10th, so it's 2.33. Right, so the Z-score is 2.33. So when I come here, right, remember that these Z-scores are uniform. So this Z-score is just twice this first standard deviation. The Z-score is just the relationship between the standard deviation and the score. So a 2.33 Z-score, right, is literally just, if I want to know what the actual, how far it is, because I know that the Z-score of 1 is equal to 12,500, isn't it? Right? I mean, that's what one standard deviation is. That's the Z-score of 1. And the Z-score of 2 is equal to, of course, 2 times this, which we did, which was 24,500. So therefore, the Z-score of 2.33 must be 2.33 times, of course, 12,500. And I will find its position, if you like, on the curve. So I will multiply 2.33 times 12,500, and you will get 29. So I'm here somewhere. I'm here 29,001. Well, sorry, the distance is the distance is 29,125. That's, well, it's not on here, but it's the score itself, the deviation, that's what I should say. The deviation is 29,125. That's what the Z-score is giving you, that deviation. Right. So now that I know this deviation, this is the degree of deviation. Remember, this is the deviation, 12,500, and then you have another 12,500, and I've also found, so now I found the deviation from here of 29,125 for this question of at what would be at 1%. So therefore, if I'm starting at 5,000, I'm saying that it can fall by 29,125, and that will take us all the way down to 24,125. So my position itself actually will be around here, 24,125. So now I have how low I can go, right? So there's a 1% chance, in effect, that you could be in this, you could be having a stock that's lower than, you could be left with less than 24,100, right? And there's a 99% chance my stock will be higher than minus 24,000, overdrawn 24,125, which is sort of what's happening sort of here, isn't it? So, so that's the first point. That's the first thing. Let me just clean, erase, just to give some space again. And let's just do another one just to sort of illustrate this again. And I think you will. So that's the first thing. Let's look at another one. Let's look at another situation with the question could ask, what about a situation? What about 5%? Right, and then because I'll come back to the language we're using, because this is all value at risk. The figure I've just calculated here, 24,125, is referred to as the value at risk, if you like. But let's talk about a 5% situation. What is a 5% probability? I'm doing exactly the same thing. I just need to understand what that deviation is. So I go back to my Z-score for a 5% deviation, and if I look at my 5% deviation, I'm literally asking, where is 5%? How far is 5%? And if you look here, 5% is just about here. That's 1.64. Yes, 1.64, if you like. Maybe 1.65. It doesn't really matter. You can say 1.64. So the deviation from the mean is for 5%, right? Because you see, 5% is the same thing as saying 5% all the way to here is the same thing as saying 95% all the way up to here, right? Everything up to here. So because the Z-score table works by looking at from here to here, so you have to find the 5%, and then you can talk about this. So you can say, well, there's a 5% chance you're going to be less than this, or a 95% chance you'll be greater than this. It doesn't really matter. So let me find the deviation. 1.64 times 12,500. 1.64 times 1.64 times 12,500 takes you to 20,500. So you have a deviation, a fall of 20,500. So if you start at 5,000, you could end up as low, yes, as 15,500. You could end up as low. So, but you can see 1.64 was always going to be around here, isn't it? You could end up as low as 15,500, something along those lines. So let's go back to the text and sort of see what the argument is. Yes. So what I was saying earlier on is what you see here, where I drew this and I said we had 5,000 here, and you can see here that you're starting at 5,000. This gives you the extent of your deviation. If someone is asking you for a 99% chance of, so 99% chance is asking you everything around here, what's happening all around here, but you need the Z-score. The Z-score gives you the value here. So when you now know this, you can get this. It doesn't matter, like we did, and you know that there's a 99% chance you will be better than this, or there's a 1% chance you will be in this area. In the same thing, we did the same thing for 5%. We did 1.64 times this, and 1.64 times 12,500, and subtracted that from the 5,000. So we know we can go as low as 15,563. So you can see it says there's a 5% chance that losses could be lower here. That's what they're saying. The losses, you could keep going lower. There's a 5, but you could say that if you were optimistic, you could say there's a 95% chance that at least, well, there's a 95% chance the other way around that you won't lose, if you like, that you're at least there's well, like I say, there's a 95% chance that your profits will be that the lowest you will lose is this. It's just saying the same thing the other way. I mean, for a 5% chance, it's all the way here. You know, what we're really saying, for a 5% chance that your profits will be higher, what's the 5% chance? You're asking that what's the chances of the profits being higher here? You know, so we're just flicking it on its head. But I think that's the first thing to say, because I've gone for 15 minutes, which is a pretty long time. But let me just kind of summarize to kind of highlight the key points. I think what's important to understand is that the value is really saying, think of you having some right. So just think of you, just in terms of summarizing, just think of you having some money in your pocket, and you're concerned about the movement in those values. We can, if I just let me just create a new, very quickly create a new PowerPoint, sorry, or just a new slide. We can discuss, using the information we have about these deviations. We can say this: I have a mean, right? Just to summarize. If I understand how this mean, if I understand the deviations around this mean, I can use the Z-score table to find, yes, the values of movement. And then I can make decisions, or I can say things, right? I can know what the deviation will be because I know what a standard deviation is. So because you're given a standard deviation, 12,500, the Z-score will help you. For example, we found the Z-score like 2.33 or times 1.64 to understand the degree of deviation. So what are you always doing? You take the Z-score, apply the Z-score to the deviation, and then adjust the starting figure for that deviation, and you will arrive at your new figure. And then you can make a decision about that new figure. You can say, oh, there is a 5% chance we will be greater here, or there is a 95% chance we will be less than here. You know, it's just what it is. We did earlier questions, so you can look back at, I think it was part 2, where we looked at questions around these calculations, and we can do different things. But I think that that's the first thing. So I'm going to do another example, a final example, to further illustrate, just because with standard deviations, as you can imagine, the standard deviation for a day is different for the standard deviation for a month, which is different to the standard deviation for a year, right? So you're more likely to have less of a deviation as you're going along. So we're just going to go along to one final example to confirm this. And as we do questions, hopefully this will make more and more sense. But this is for theory, for you to understand the theory. Okay.